As I told you, that is H is depends upon what? It depends upon current and what? Current and geometry. Geometry of the conductor. Geometry of the conductor. That means whether the conductor is straight or circular or triangular or what, it depends upon the shape of the conductor. Whereas B is called as a magnetic induction. That is, I told you it depends upon H, and also it depends upon what type of the conductor, not type of conductor, type of the what material depends. What it means, I'll tell you now. Students, now let us consider a magnetic field. You consider this is the magnetic field. I will call it as a what? H. This is magnetic intensity. Magnetic intensity. This is purely the air medium. Actually, it is vacuum, that is not air. Actually, it is. Now I will consider one material, cobalt or something that is any nickel, iron, anything material you consider. When this material is placed here, then what happens is magnetic field will be there here, is inside. Here you see, one is H. Here B total equal to or B net equal to, what happens is B net equal to B internal plus of what? B of what? External, that is. Now you have to ask question, what is B internal and B external? B external is nothing but H. What? External. It is a magnetizing field. B internal is nothing but what? Here, whatever that is in the material, that is atomic orbits are there. Now, they will arrange in one particular fashion, they will arrange. All they will orient. All they will orient in the direction of the what? External magnetic field. This I will call it as a what? I, that is. Try to understand. B internal is nothing but I. Some books they will write M, they will write. Some books they will write I. It is because of what? In a material, what is there? Atomic magnets are there. Just I told you that is. All atomic magnets, they will orient in one particular direction. I will give one example for it. It is nothing but what? Each atom is nothing but students you can consider in a classroom. In the absence of teacher, what happens is all students, they are oriented in a what? Random direction, that is. All students are in the random direction. Like this. In the absence of teachers. Each student is considered as a one atomic magnet. Here, when the teacher enters into the classroom, what happens is, each student will be oriented in one particular direction. He is facing towards the board and all that. That is nothing but what? Here, all these atomic magnets, they will orient in one particular direction. This also, it produces the what? Magnetic field. This is called as what? Internal magnetic field, I will call it as. And this value, I will call it internal magnetic field, is represented by either I or else they will call it as a what? M, that is. In magnetic, they will call it either I or else what? Yeah. This is nothing but what? B net. B net. That means the total magnetic field, it depends upon what? I and H. But the beauty of this is the value of this I. The value of this I is differs from one material to what? Another material. It is again the student tendency, that is. The student tendency. I can't expect that all the students should sit comfortably in only one direction for the primary level students and all that, for the LKG students and all that. But I can expect that kind of students, the moment I entered, all students should orient in what one particular direction towards the board, that is. Here, that's why the student means whether he's studying the first standard or second standard or B.Sc 3 or something. Like that, here, each atom is nothing but what? Atomic magnets. This orientation will be it produces the what? Internal magnetic field. And the value of this will be differs from one material to what? Another material.